Hello, Algebra 2s. Trying to get this video done and knock it out, get it up online for you. I know Kayla was like totally mortified that I hadn't made it yet. I'm sorry. I promise I'm doing my best. But you guys are doing awesome. I'm very proud of how we've done. Today we got a lot more done today than we got done for a while. Hipster Kitty and I are going to walk you through the free response style questions on your semester 1 exam. Let's jump right in with the sheet that you got. If you've already tried them, fabulous. If you haven't, please try it on your own first, then resume watching the video. Okay, starting with the first one. So we're solving this first equation, and we are solving this equation for the x, and we know that we are supposed to do a couple of things. One, we are supposed to isolate that radical, so let's go ahead and do that. So I have the square root of 3x minus 2 minus 8 on the outside equals 11. So I'm going to add 8 to begin with, making that 19 on the right-hand side. And square root of 3x minus 2 on the left. We now know we're going to square both sides. So we have to get rid of the radical in order to solve this. So you're going to isolate that radical. A couple of things. Remember that you could see this 3x minus 2, the quantity to the 1/2 power, and that means the same thing as what you see here right now. So that is one thing to keep in mind that we struggled with in class a little bit. Once we square both sides, we now have 3x minus 2 equals, and we're going to square this 19. And I don't know the value of 19 squared, so I'm not embarrassed to tell you that that's the sound of me opening a calculator because I don't know 19 squared. 361. And we're going to add 2 to each side. So that'll give me 3x equals 363, which is nice because that's going to come out evenly into 121. All right, other issues we could encounter with a radical like this. Remember, you could need to square the right-hand side and end up needing to FOIL. Remember that when you square a binomial, some of you got caught with that today, that you do need to FOIL. And let me find you some page numbers for radicals like this. In the purple book, that would be page 389. Gives you some basic radical equations. And if you need me to go over any of them or work through any of them for you, let me know and I'll post a PDF. Next one, excuse me. Next one we are factoring, and we are factoring this difference of cubes right here. So I'm going to come down here to the bottom of my screen, and I'm going to factor it right down here, and then I'll probably have to go ahead and do the same thing for the next one, but that's okay. All right, so I have 27x cubed minus 64y cubed. Okay, so 27x cubed minus 64y cubed. The point where I've noticed that we've struggled with this a little bit is, first of all, identify what it is that's cubed. Write that down. After that, it's memorizing a pattern. Memorizing a simple, repeating pattern that is the same every time. So we know that 27 is, oh, I caught it. Sorry, I caught it. I made a mistake. Hold on. Can I erase that? Yeah. All right. So we know that that's 3x, the quantity to the third power, and 64y cubed is 4y, the quantity to the third power. It's binomial, trinomial. All right. And let's look at what the pattern is if we were using a cubed minus b cubed. The binomial is always the same sign as what's in the original expression, except it's the cube root of each term. So a and b, not a cubed and b cubed. Then this is a squared, the entire quantity of what was in a squared for that first term, plus a times b plus b squared. That's the pattern we're looking at here. So that means that this is 3x minus 4y. That's pretty straightforward. This right here is going to be 3x, the quantity squared, making that 9x squared. And then over on the end here is going to be 4y, the quantity squared, making that 16y squared. In the center, we're multiplying them together, 3 times 4 and x times y, so 12xy. Oop, my plus sign in there too. So 3x minus 4y first, 9x squared plus 12x plus 16y squared. And looking up here at the format of how this question is given to you up here, you're identifying all the factors. So we know we need 2 of these selections. And all of the different possibilities are going to be in there, so you really need to know what you are doing. A couple of them that we can notice are definitely wrong, like this one, obviously wrong. We didn't even take the cube root there. And this one, because we know the binomial will match the sign in the original problem. So we know this is one of our answers right here. And now we've got to look at our other three possibilities. I can see this clear mistake because we know it's the quantity 3x squared, so it should have been 9x squared, so it can't be that one. We've got the last two. The pattern you want to remember here is that if the binomial is negative, okay, that second term is a subtracted term, that middle term is going to be added or positive. So that finishes out the problem right there. Okay, let me find you a page number for problems like this one. And sum and difference of cubes you can find in your purple textbook. That's why I'm writing it in purple. On page 324 to 325. Let me go ahead and make a new slide for number 3 because we are completely out of space, and I will continue on in a moment. All right, continuing on, we are going to factor this gigantic polynomial up here at the top. Now, I want you to always start by looking and seeing if you can just go ahead and factor it by grouping. And in this case, you actually can. But I also want you to remember that you can graph this polynomial, just make it y equals. I'm going to go ahead and do that on the graphing calculator right here in front of me. And then I'm going to go sketch the graph for you so you can see what it looks like. But of course, you can be graphing this yourself at the same time. Minus 3x plus 15. Okay, graph. And so this should help me find one of my factors. And it does indeed help me find, helps me actually find several of my factors. So you could very well take this and graph it on your TI-84 plus. And let me go ahead and graph what it looks like. It goes right here through -1. And then it goes way up above the graph, and then it comes down here and goes through +1. Right there. And then 2, 3, 4, 5. Oh, okay. So, and it goes off the graph. So if this is like my graphing window, totally goes off the graph and then comes back up and goes through 5. So -1, 1, and 5 are the zeros. Well, that's awesome because that is very helpful that we can see that. So that should help me partly find my answer. Okay, I can now use synthetic or long division. And I can put in one, DIR, really? Let's try that again. How about DIV? Division. Okay, so I can use that, but as I said, we can always try to factor. I'm trying to give you strategies for any problem. If we use synthetic or long division, you would use one root, and you could, in this case, use -1, 1, or 5, and then you could divide out and then divide what you have left until you can't divide anymore. Just remember, if -1 is a root, that means that the factor is not x minus 1, it's x plus 1. But going back to the method of just actually factoring it, let's go ahead and do this problem out that way. So I'm going to start off by taking out a 3, and I'm looking up at the top of the page here, and I'm factoring out a 3. And I get this. Now I can look at it and say, hey, can I factor by grouping? I sure can. So I'm going to look at what the first two terms have in common, which in this case is an x squared, leaving x minus 5. And then how do I get that to leave x minus 5? Well, I take out a -1, leaving me 3 times x squared minus 1 times x minus 5. But I'm not finished yet, and I should recognize that because this is a difference of squares. So I still have one more step. I've got my 3. I've got x minus 5 that I had from before. And then if I factor that difference of squares, I have x plus 1, x minus 1. And those are all of the factors I need. So going up here to my answers, I can circle the ones that actually match. Notice I am not circling that one. That is there to trip you up. That is there to make you think, oh, well, I got that. But you didn't finish because the keyword here is factored completely. All right, let me find you a couple of problems like this one. Well, just lo and behold, there happen to be several of those on the same page we just used, which is page 325, again, in the purple book. All right, moving on to the next couple problems. Okay, here we go with 4 and 5. So this first one, we struggled a little bit with this today. I want you to remember that you have to FOIL this. Only when the two are conjugates will you end up with an expression that doesn't have a radical at the end. That would be if we had 3 minus root 5 times 3 plus root 5. That's one that would come out to 9 minus 5, which is 4. So you don't need to worry about that middle term when they're conjugates. But these are not conjugates. These are different because of the numbers being different. So we have to FOIL this. So first is negative 12. Outer is 3 times root 5 or plus 3 root 5. Inner is minus root 5 times minus 4 or plus 4 root 5. And last is minus root 5 times root 5, and minus root 5 times positive root 5 is minus 5. So a radical times itself gets rid of the radical sign, you just get the radicand, that number inside. Combine your like terms. Negative 12 and negative 5 is negative 17, plus 3 root 5 and 4 root 5 is 7 root 5. Giving us correct answers of the negative 17 and the plus 7 root 5. And again, you can practice this in your textbook. Binomial radical expressions can be found on pages 376 and 377. Last one, I made a little mistake here, so go ahead and make a quick change. Make that exponent 5/4. And if you were trying the problem and you were completely lost, that would be why, because I'm special like that sometimes. I am so sorry. Just bear with me, okay? We are just looking for which expressions are equivalent to this one, which is 12x the quantity to the 5/4 power. Okay, so what we're trying to recognize here, and this is what I want you to emphasize, top number, exponent, bottom number, index. So our index goes on this radical sign, and our exponent goes on this expression, like so. So that's the correct one for that, but there is another way to express it. Now, I'm not guaranteeing you that there's going to be 2 correct answers to a problem like this. I'm actually going to go ahead and tell you when you're taking the exam whether there's 1 or more correct answer, even though that won't be possible in the SOL. I've made an executive decision. I'm the one giving the exam, so I'm going to tell you that part. And we want to think about the other way we could write this. There is one other way. Remember that we could take the 4th root of 12x and put that 5 exponent all the way on the outside. That is also acceptable. Okay, so that's this one. All right, so we need to know where can we find some problems like this that we can use to practice. Where would the rational exponents be found? And where would that be? That would be, again, in the purple book, 382 and 383. Okay, the last problem is on the last slide. Let's get to it. Okay, this one's actually the fastest one we have yet. Where we get tripped up on with this is the fraction. The fraction is the one that's going to mess us up. We know if negative 3 is a root, then x plus 3 is a factor. So I know I've got that one, not that one. We know if 6 is a root, that means x minus 6 is a factor. So I know it's not that one, it's the one with x minus 6. Now with this one, what I want you to do is make x minus 2/3 equal to 0. Because that's like going another step. If I go another step back, x equals positive 2/3. If I subtracted 2/3 from each side, I get x minus 2/3 equals 0. Then, in order to get rid of the fraction, and how do I know that there can't be integers in here? I know it's got to be, or can't be fractions in here, excuse me. I know it's got to be integers because they tell me my expression, my answer has integral coefficients. Even if they don't tell you that, you're not going to see fractions in these selections. So how do I reconcile those fractions? How do I get rid of them? Multiply the whole thing by 3. 3x minus 2 is still equal to 0 because 0 times 3 is 0. And that's your third factor right there. So that wasn't too bad. Let me find you a page number with a couple of those. You can find several of these on page 311. The one on the exam is like this, where they're all real numbers. But if you want ones that are with the complex numbers and you had to multiply it all the way out, which again, you know, I don't think you're going to see one like this on the exam that has complex numbers. But if you wanted to practice a few more of those, that would be page 333. All right, guys, thanks for hanging in with me and thanks for being so patient today. If you have any questions, post them on Edmodo. I'll see you in class.